The Pythagorean Theorem. This is, believe it or not, in the history of math, maybe the history of the world, one of the most important and pivotal things that was ever discovered by anyone. But this guy's name was Pythagoras, hence the Pythagorean Theorem. So what is the Pythagorean Theorem? Well, it shows the relationship between the length of the three sides of a right triangle. Now, you remember we talked about lots of different words that describe triangles: obtuse, acute, right, equiangular, equilateral, isosceles, scalene. This only applies to right triangles. The Pythagorean theorem does not work on anything else, just on right triangles. The formula is fairly easy to remember. A squared plus b squared equals c squared. Now, A and B represent the two legs of the triangle. These are the shorter two sides. C represents the hypotenuse. This is the longest side, and it is always the side directly across from the right angle. So let's label this triangle to make sure we understand what pieces we're talking about. So two of the blanks we should put leg, one blank we should put hypotenuse, and one blank we should put right angle. So I think the last one, sorry about that, the last one's probably the easiest. The right angle is the one pointing to an angle, and I'm pointing to the angle with the box because that box implies that it is a right angle. Okay, the side directly across from the right angle, it's also the longest side, is called the hypotenuse. I admit I don't know where that word came from, but it's one you need to remember, hypotenuse. It's the longest side, and it's the side opposite the right angle. So the other two sides are the legs. So this is a leg, and this is a leg. So the legs are the sides that stretch out from the right angle. The hypotenuse is the one that's opposite from it. Now let's apply this. A squared plus b squared equals c squared to these problems. So here's the c. C is the hypotenuse. It's always what's directly across from the right angle. So we don't know the hypotenuse. We do know the two legs. It doesn't matter if you call this a and this b, or this a and this b. It'll work either way. But we get 7 squared plus 8 squared equals c squared. Seven squared plus 8 squared gives us 113. But we don't just want c squared. We want to know what c is equal to. So to get rid of that squared, we do the opposite and we square root both sides. When I take the square root of 113, I get 10.63. They say around in the nearest tenth, so we'll say 10.6. Now on number 2, they do give us the hypotenuse. It's one of the legs we don't know. You can call this the A leg or the B leg, doesn't matter. I'll just say x squared, because that's one of the legs, plus 12 squared is equal to 37 squared. Because no matter what, you've got to put the hypotenuse as the one in for C. So this one's a little bit different. Last time we added the two together. This time we'll subtract because we want to get x by itself. So I need to subtract 12 squared from both sides. $37 squared minus 12 squared gives us 1225. So x squared equals 1225. Then we need to take the square root of both sides. And we get 35. So the leg is equal to 35. Now there are times they may not give you a picture. If you want to draw a picture, you can. They say given a right triangle, if side A is 4 inches, side B is 10 inches, so those are the legs. I know that just because they're labeled as A and B. It says what is the measure of side C? And that has to be the hypotenuse. Now they can use X and Y, things like that, but when they use A, B, and C, A and B are always the legs, C is the hypotenuse. So this will work very similar to how we did number 1, because it's the hypotenuse we're looking for. So we'll say 4 squared plus 10 squared equals C squared. You can type that in your calculator. 4 squared plus 10 squared is 116. But then we need to take the square root of both sides. So we'll take the square root of 116. And we round the nearest tenth, or actually, yeah, round the nearest tenth. So we look here, we're right now at 10.7, but the number after that is 5 or higher, so we should round this 7 to an 8 and say it is 10.8 inches. So they did not give us any units, number 1 and number 2, that's why I didn't bother. But here they did give us a unit. They said it's 4 inches and 10 inches. So we get 10.8 inches. Okay, then number 4 is more similar to number 2 because again, this time it's a leg we're looking for. Because they tell us side B is 14 inches and side C, which has to be the hypotenuse, is 40 inches. So what's the measure of side A? So we'll set up the Pythagorean theorem as A squared plus 14 squared equals 40 squared. But to get A by itself, we'll need to subtract 14 squared from both sides. So 40 squared minus 14 squared gives me 1404. Then to get rid of the squared on the A, we take the square root of both sides. So the square root of 1404, we round that to 37.5 because the number after this is 5 or higher. So we'd round this up to 5, and so we'd say A is equal to 37.5 inches. Okay, we'll just keep practicing on the back. So we're given sides A and B. So I'll do 25 squared plus 20 squared equals C squared. Let's see, 25 squared, I think that's 625. 20 squared is 400. So that's a total of 1025. And then we take the square root of both sides, and we get 32.0, notice it said the 10th this time, inches. Okay, so in that one we were finding the hypotenuse, that's why I plugged in for A and B and solved. This one will be solving for a side, because they did not tell us A, but they did tell us B, and they did tell us C. So 40 squared is 1600. You can of course do all this in your calculator. 44 squared is 1936. Sorry, this should be a plus, not an equals. So then I subtract 1600 from both sides. I get A squared equals 336. So then I take the square root of both sides, and I get that A, a side, is equal to 18.3 inches. Okay, this one we're also solving for a leg because we know C, the hypotenuse, in one of the legs, but not the other. So 10 squared plus B squared equals 20 squared. 10 squared is 100. 20 squared is 400. So I'll subtract that 100 over and get B squared equals 300. So then I take the square root of both sides, and rounding to the nearest tenth, I get that B is equal to 17.3 inches. Okay, last one, we're again solving for a leg because we don't know A, but we do know C, the hypotenuse. So I write A squared equals 30 squared. Nope, let me try that again. a squared plus 30 squared, because it's a squared plus b squared, is equal to 48 squared. So 30 squared is 900. 48 squared is, I think it's 2304. So then we subtract 900 from both sides. We get a squared equals 1404. Then we take the square root of both sides, and we find out that a is equal to 37.5 inches. So hopefully that gives you some comfort with the Pythagorean theorem. Now, there is one more thing we want to talk about with the Pythagorean theorem. So, like I said, when they don't give you a picture, which they didn't on any of them, I recommend you draw one. But one thing I also pointed out was that the Pythagorean theorem only works if we have a right triangle. A squared plus b squared only equals c squared if it's a right triangle. So, one other way we can use the Pythagorean theorem is determine if a triangle with certain side lengths is or is not a right triangle. Because if we plug in the smaller two sides in for A and B, and we plug in the longest side in for C, if these two sides are equal, that means it is a right triangle. But if they're not equal, that means it's not a right triangle. So let's try this out. So identify whether each set of side lengths belongs to a right triangle. Justify your answer by the Pythagorean theorem. So just like I said, you want to plug the smaller two sides in for A and B. So that's the squared. Plug the longest side in for side C. So let me make it so we can get a calculator in here. So 5 squared plus 6 squared is 61. However, 7 squared is 49. So those are not equal, which means no, it's not a right triangle. And this is all you have to do to prove it using the Pythagorean theorem. You just show that if you plug those sides in, either it is equal, proving yes, or not equal, proving no. So again here, we plug in the smaller two sides first. So I'll test this. 55 squared plus 48 squared. That's 5329. Just write it there so we remember it. 73 squared. Hey, that's also 5329. So that is true. Yes, these sides can form a right triangle. Okay, so for C, we plug the smaller two sides in for A and B. We plug the longest side in for C. So 8 squared plus 15 squared is 289. And guess what? 17 squared is also 289. So yes, these can form a right triangle. So for the last one, we plug in 8 squared plus 9 squared equals 12 squared. So we want to see if those are equal. 8 squared, let me try that again. 8 squared plus 9 squared is equal to 145. But 12 squared is equal to 144. So that's actually pretty clear and close. But they are not equal, so this cannot create a right triangle. Okay, final answer. A volleyball court is 30 feet wide and 60 feet long. And notice how the first thing I did was I drew a picture because I wanted to make sure I knew what was going on and could see and interpret things correctly. So a player serves the ball from the corner of the court to the opposite corner of the court. How far is this? So if you're at this back right corner And from your point of view, you're serving it to the back left corner. You're creating a right triangle because this is a rectangle. So these are all right angles, So this up here is a right triangle. So this, because it's across from the right angle, is the hypotenuse. So we could set it up and say 30 squared plus 60 squared equals c squared. Let's see, 30 squared plus 60 squared is 4,500. And then we need to take the square root of that to equal c. I think that's that one right there. So square root of 4,500. We'll round to the nearest tenth, so that's 67.1 feet. So the length of her serve, or his serve, from the back corner to, well, from his corner to the other corner is 67.1 feet.